Hello. Alright. Now we go for this example under the concept of equation involving logarithms. Okay. So if they say involving logarithm means that you need to use the law of logarithm or the rules of logarithms. Okay. When they say equation involving indices, you need to use the law of indices, right? So now, okay, logarithm. So for this case, right? So you have to very good in using the formula for logarithm. So for this case, you can see that actually you must see the pattern, right? The pattern. So you have x here, then you have base x here, right? So it's better for us to have the same base before we solve the equation. Okay, the clue for solving this type of equation where the base are different is we must change the base such that all the base of the log have the same base, okay, or all under base x, or maybe all under base 4, right? 16 and 4 have the same base. All right. It's actually very you must have very systematic in choosing the right way. So for example, okay, log x base 4, I'm not going to modify this because I think that there's a number 4, right? 4. So this is the one that I need to modify because 4 already does base for 16. So 16 is the one that need to convert. So what formula is involved for this? Okay, I may revise these two formula. Let's say you have log b base a. You may using log b over with log a. Then you change to other base c. Any base that are suitable to simplify the log. Okay, this is the first formula. The second formula that you learn will be, let's say if I have log base a, you can 1 over, then the b become the base and the a become the value inside the log, right? This is the two only formula for changing the base of a log. So this case I may use the first one, all right, the first one. So I can rewrite this as log 16 divided by log base 4, right? Log base x, right? 16 over log base BA, right? BA, log B over log A at C. So what do you think? What's the suitable base here? Of course, it must be 4, right? Because I'm going to change such that it can have the same base with this 4. So I put 4. Now you can see it's very easy later. Okay, log x base 4. Alright. Log 16. Okay, log 16 base 4, right? I want to simplify this one. So it's actually log 4 to the power of 2, right? Then you can bring 2 to the front and log 4 base 4. So this one you have 1. So 2 multiply 1, you have 2. So you have know that you have simplified, become 2 over log x base 4. This is your objective. So alright, now you can see these two are identical. So usually we will ask them to assume, because they have the same unknown. Assume y or u equals to log x to the base 4, right? Log x to the base 4. So you have to replace this with y equals to 2 over y, right? Y equals to 2 over y. Then you can solve this just like a quadratic. You have y square equals to 2, right? Y square equals to 2. Then y. So y is positive negative of square root of 2, right? Positive negative of square root of 2. So now y is not the solution for this equation. So you want to find the x. Okay, you want to find x. So you know that y is equals to y is equals to square root of 2, or y equals to negative square root of 2, right? Positive negative 2. What is y? Y is log x to the base 4. Log x to the base 4 equals to square root of 2. Log x to the base 4 equals to negative square root of 2. So now you want to find the value of x, so you have to apply this log b base a equals to c. So you can convert, become index form, logarithm form. So index form will be b equals to a to the power of c. Same thing also, x equals to 4 to the power of square root of 2. And for this is x equals to 4 to the power negative square root of 2. You can change, become decimal, right? So to calculate the value, so 4 square root of 2, right? 4 to the power, 4 to the power of square root of 2. So you have 7.103, right? 7.103 for this case. 103. And for this, you have 4 to the power of negative 2, right? So I put negative in front here. Put negative. Then I have 0.141, all right? 0.141. All right, these two will be your solution for this problem. All right.